So in last class, we were discussing about a program in which we wanted to sum 5 data byte, and this is that program. This is the final program that we have written. Okay, what does this program do? Let's quickly revise. Uh, Basically, we have 5 data byte array at D500 onwards. That means D500, D501, 2, 3, and 4. These are the 5 locations where I have data. Now what I'm going to do, I'll start with my register C because we are going to store all the carries that is being generated in register C. That's why I am first clearing register C. Then I'll bring in my first data in accumulator using the instruction LDA. Then I'm going to move the first data in register B, and then I am going to bring in the second data in register A again. Then I am going to sort A plus B. And so my answer would be A. If the carry is generated, then I am going to store the carry by incrementing register C by 1. So if register is 0, now it will become 0, 1. But when will happen? If carry is generated, then and then this will happen. Otherwise, if there is no carry, then what will happen? Jump on no carry instruction will be true, and it will jump to this location, that is FWD1. This is the location FWD1. Okay. Then I'm moving my next uh, before bringing my next data byte, I'm going to move my answer in register B, and then again I'm going to move a new data in register A. Again I'm going to perform the sum. Again, if the carry is there, I'm going to increment C. If no carry is there, again I'm going to. So now, main thing is that we see a lot of instructions that are reappearing, and I don't want that. Okay. So just to do the same task multiple times is not the good thing. Doing, we are repeating same task continuously, and that's not the good thing. So what we are going to do is we are going to write a program in such a way that this task that are repetitive in nature. See, this is the repetitive in nature. This loading accumulator, though address are different, but again, you can see the same code over here. Okay, the only difference is this D503 and forward 2 instead of forward 3. Okay. Same code is appearing over here, and same code is even appearing over here. So these are repetition of the code, and who we do not want it. So this is the correct program. It will give you the correct output, no doubt in that. But my concerns are the program that you are going to write will consume huge memory. Why it will consume huge memory? Because you are writing the program repetitively. See, this is the part of program that you are repeating continuously. So what you can do, you can create a loop here, and that loop can continuously execute. So using same code, you can execute number of you can execute number of times the loops, and you can do the data operation number of times. So the first thing is it's consume huge memory. That's the main issue. So I want to be efficient in the programming, and I want to my program to be very efficient. So how to do that? So to do that, you must know a new instruction, and that instruction is uh, okay. So what we are going to do now is we are trying to reduce this program, and to do that we are going to learn a new instruction. Why we have to learn a new instruction? Because you can see here their address is changing every time. Earlier it is D503, D502, D501. So we have changing addresses. So how to manage the changing addresses? That means how to get the data. If the data is like 5, 10 bytes or 20 bytes of data is there, how to get that data? So to do this kind of task, we have a special function or a special function register known as a memory pointer. we have a special register named as a memory pointer. Okay, now this is not a new register, it's just a way of saying this. Actually, the register involved as a memory pointer are register H and L. Okay, these two will combinedly make a pair, and inside that pair, so these two are 8-bit registers, so combinedly it will hold your 16-bit address. And what it will do, it will point to specific address. Okay, which address? Given by content of HL pair. Okay, so memory pointer is nothing new, it's just a way of saying uh, things. Okay, now how a memory pointer work, or how we are going to use a memory pointer? It's very easy, we have done this earlier. You know this instruction, move rd comma rs. What happens? Source to destination. Same way, to use a memory pointer, we have two instructions. First is move rd comma m. Second one is move m comma rs. Okay, so what this instruction will do, this instruction will take the data from memory and put it inside your register. Now this registers can be any register. Okay, it can be your A, B, C, D, E, H or L. It can be any register. Same way, here your RS can be any of this. So this is the operation which can perform the data transfer between your memory and your register. But which register? Any register. Your LDA and STA were the two instructions which can read and write to memory, but this was limited to accumulator. So they can either read the data of memory and put it in accumulator, or write the content of accumulator inside a memory. Okay. Again, address is given over here. Same way, address will be given when you are using this instruction. So now the thing is, how I'm going to write the address then. So whenever you write this instruction, what will happen? Let us see with an example. Let us have a data. Let us say my data is we have the data. We have the previous data. We go there in the data. Yeah, let us have this data. Let us say I have this data. Okay, and I'm going to write 3 lines of code, and what will happen? Let us see. The first line, very first line is, let us say MVI H comma D5H. Okay. Uh, then the second instruction, let us say MVI L comma 0 to H, and then I am writing a last instance, that is move B comma M. Okay, now see, this is the instruction which represent this instruction, move rd comma m. So memory to register B data transfer is that, but which memory? What does that m means? M means your memory pointer, and your memory pointer use HL pair, content of HL pair as an address. So when you write this instruction, what exactly will be done? A memory pointer, so you can say HL pair, we know the content of HL pair, combinedly it is D5 02. So what this instruction will do, when you write move B comma M, at that time it will use the content of HL pair as address. It will go to this address. So where is D502? In our case, D502 is this one. It will go here. It will bring the data A6 inside your register B. So after you execute this instruction, your content of B would be A6H. Okay, clear? Any questions? Any questions? No questions. Okay, very good. Now let us see one more example. What I am doing now, how to write a data. So let us say I have an instruction MVI H, D5H. MVIL, comma 05H, and then I am routing move M, comma B. What this will do? Can anyone help me? Roll number 2 is there? Yagnesh. Yagnesh, what this program will do? Yagnesh, what this program will do? First instruction is MVI HD5, MVI L05, MOV M, comma B. Okay. Yagnesh, Yagnesh, please turn on your mic. Okay. He might be not there. Satish,
Yes, sir.
can you help me with this? What this program will do? This program.
It will data transform from register B to memory.
Okay. But what is the issue? We don't know what is the content of it. That's why I cannot say what will go over there. But let us say I have one more instruction, MVIB, comma 00H. Now what will happen? Exactly what will happen? Can you help me with that? See what will happen again whenever you see M, immediately look at HL pad as an address. So okay, so my address become D505. What I'm doing, B to M, so it will go from B to M. Where is M? M is given by this address, so actually this is the address of memory, so it will go at D505. See, this is D505, and it will put data over here as 00. So I am writing a data to my memory using memory pointer. So these are the two operations using a memory pointer, and there are so many like operations that can be possible using a memory pointer. There are so many instructions related to memory pointer. Okay. So why I am like saying this? I am saying this because to create the loop that can automatically change its address. See, I want to change my address. Okay, I want to go from D503 to D504. How I can do automatically? See, here it is incrementation by 1. So if I perform INR, in that case, I can automatically form a loop which will loop through some part of program and do the repetitive task. Okay, so now let us see the program. But here I have a little bit issue. What issue? Issue with INR. I have an issue with instruction INR. Now INR is the instruction when we have learned a flag register at that time. I have told you that some instruction will modify the content of flag register, and INR and DCR are the instruction which can modify the status of carry flag and zero flag. Okay, this is the instruction which can modify the carry flag as well as zero flag. Okay, so whenever you are using this along with arithmetic operation, suppose you have performed this operation add b, and after that if you are doing INR C, let us say, at that time what will happen? Whatever is the carry, whether it is set or reset, but it will be modified while performing this operation. So suppose here carry is set, but here the operation is such a way, let's say it was 05, it is becoming 06. At that time carry will not set, so carry will become 0. So whatever the content you get during the previous operation will be lost if you do not take care while using INR and DCR. That's an issue. And to solve that issue, I am going to introduce two new instructions. Very basic instructions are there. The first instruction is LXI, and second and third instruction is INX and DCX. Okay, what this do? Whenever you see X inside any instruction, most of the time, whenever you see X inside any instruction, at that time, that operation is mainly related with register pair. That's the thing. Okay, Now what is a register pair? We have seen one register pair HL already, and there are two more pairs, register pair BC and DE. Okay, so these are the three pairs, register pairs are there, three pairs. Okay, so if you want to access register pair, you have to instruct your 8085 accordingly. Okay, so there is a specific instruction set related to register pair. So if I write LXI RP and some 16-bit data, okay, I'm going to give you example what I am doing. LXI RP 16-bit data. What is RP? RP can be your BC pair, your DE pair, or HL pair. How to write this instruction exactly? I am going to write it like this. LXI. Let us say I want to write this instruction. I want to move D502 as address. So what I'll do? I'll move LXI. Instead of move, I'm going to write LXI H, comma D502H. What this instruction will do? This will take inside the 16-bit data and move it in this register HL. Okay, see, it's just single H, but actually the instruction is LXI, and it itself represent it is a 16 pair, like 16-bit operation, or you can say it's a operation which is involved in register pair operation. So whenever you see H, actually it is HL. Okay, so if I'm using MVI and if I writing H, then it means H only. But if I writing LXN and I'm writing H, that means HL pair. Same way if I write NNX with H or DCX with H, at that time also this represent two register HL combining. So this instruction is actually similar to MVI. Okay, when you write MVI H, let us say MVI comma 05, what will happen? The content 05 will be stored inside register A. Both is 8-bit, but here my content is 16-bit as well as my register pair is 16-bit. So this instruction will take up this 16-bit data and it will store inside register H and L. So H will become D5 and L will become 02. So just using this single instruction, you are going to do this two tasks. Okay, how I supposed to do that? By writing MVIH D5 and MVIL02. But instead of writing two separate instructions, I can do that using one single instruction, and that is LXI. Okay, what is this? This is load register pair. Okay, this instruction is load register pair immediate. Okay, so this instruction will load the register pair by immediate data. The size of immediate data would be 16-bit. So what would be the size of this instruction in memory? It would be a 3-byte instruction. What would be the operation? 3 operation: opcode fetch, memory read, and again memory read. Three operations would be there. So this is the instruction LXI. What it will do? It will move the 16-bit data in register pair given either B, C, D, or HL. To represent any pair, you just have to write the first register. Okay, so you will not see LXIL. You will not see that. That's not part of your mnemonics. The part of mnemonics is LXIH, 16-bit data. It is there. Opcode will be there for this. So opcode fetch and two memory. Two memory read, one for D5 and one for 02. So actually, if 2000 is the starting location, first you will have opcode. On 2001 you will have 02, and on 2002 you will have D5. This is how you will be storing this instruction. Okay, clear? Any questions? Any questions? Okay, now let us try to formulate the program. So I'm going to use Word file for that. Now see, the program will become very easy using this instruction. The first line itself would be, let us say, first of all, I know my first data is starting from D500H. This is my first instruction. What I am doing, I am moving uh, the content D500 in HL pair. Okay, so H will have D5 and L will have 00. Next instruction, what I can do, I can move that data inside which register I should move it now. See what I'm going to do next is move B, M. So what I am exactly doing, I am loading register B with data of D500. So I'm bringing this data inside. I'm bringing this data inside register B. Okay. Then what next task is, I'm going to add this B with my accumulator. Okay. I have done this. Now what I'm going to do, I'm going to add that with accumulator. So now I don't know what is the content of accumulator. The issue is I don't know what is the content of accumulator. So I have to make sure my accumulator is empty. So what I'll do, I'll clean up my accumulator by storing 00 inside there. So now what I am doing, see again I am repeating here. I am writing LXI HL. What this will do? LXI H will load HL pair with D500. Then I am writing move B, comma M. I have written M, that means it's address D500. Okay, that means it's HL pair and HL pair contains D500. So what this will do, it will go to D500, bring in whatever is the data inside register B. That is the task. Okay, so I have my first number inside, and what I am going to do, I am going to add with accumulator. But what I have done, I have make accumulator 00. Why? That I'll explain you later why I have done that. But I have done that intentionally. I have make accumulator 00 and I am adding a plus b. So what will be my answer now? A would be 99. Then again I have to check for carry, though carry is not generated over here, I am sure about that. But also I am going to check for carry. Jump on no carry to forward. Okay, if carry is there, what I'm going to do, I'm going to increment a register which will look after the carry. As soon as you write that C over here, you have to make sure your C is empty. So what you are going to do, you are going to write C, it is empty. Okay. So this is how you can formulate a program. So INRC, okay. But if that's not the case, if that's not the case, what should I do? Okay, now someone has to help me. If carry is not generated or if carry is generated, what is the next step? What will be the next step? Someone has to help me. What should be the next step? See, I have added my first data byte with 00 and I will look after the carry. Now what should I do? I should go to my next data byte, and next data byte is on the next location. That means what I should do, I should load my HL pair with D501. If carry was not generated, then I am going to jump over this location. If there is no carry, I am going to jump over this location. Then again what I am going to do, I am going to bring the next data in register B. Now see, what is the content of accumulator right now? It's 99. It's 99. Okay. So what I can do, I can directly bring this inside register B because register B is empty right now. Not empty actually, but my answer is now A in its, like it's an A itself. In earlier program we were moving it from here because the ST and LDA use accumulator, but this instruction does not use accumulator. That's why I'm going to use accumulator directly. So what I'm going to do now is move M comma B, and then again I'm going to write add A. Okay, again I'm going to check for carry, so jump on no carry to forward, and then again I'm going to repeat INR C. So see, this program over here and this program over here looks identical. Same way, if I want to go with the next step, then I am going to repeat this program, but by writing here D502. Okay, same way I'll repeat it 2 more times. So see, this part of this code is identical. Okay, only thing that is changing is this address, so I have to somehow change this address. That's the thing. Okay, now let us see how to change that address. So change that address, we have two instructions. We can do it by two way. One is the one way is using. Let me write it somewhere else so you have a better view. See, what is the content of HL right now? It is D500. Okay. Now to increment this location to D501 and then D502 is my task. Okay, automatically. So I can do this thing by two ways. First way is this, and second way is this. Okay, what's the difference? This instruction is 8-bit increment operation, and this instruction is 16-bit increment operation. Okay, so what does that mean? If I write INXH, my content of D500 will become D501, and if I write INRL, at that time my content of H will be as it is, only my L will change from 00 to 01. But still combined, if you look at this, it is D501. Then why is the separate instruction is there? The separate instruction is there because if, let us say, my content of L is FF and H is D5. Okay. Now see what happens. My content of H is D5 and L is FF. Okay. Now if I write INRL, what will happen? My H will become D5 only and L will become FF plus 1. It will become 00. Carry will be generated, but I am not taking care of carry. And if I write INX, at that time what will happen? It will change D5 FF, it will make this plus 1. So it will automatically get the answer, that is D600, and D6 would be inside H and L would be 00. So this is a 16-bit operation. This will increase a register pair by 1, and other than that, there is one more advantage. This will not alter your carry flag or 0 flag. This will alter your carry flag and 0 flag. Okay, so if this happens, carry flag will set. If this happens, no carry flag will set. That's the thing. So whenever you are using a memory pointer, at that time I am going to use INX just to make sure this kind of case cannot happen. What happened here? See, it should be actually I want it to be D600, but as I have written INRL, it's an 8-bit operation. That's why it is resetting L to 00, but it does not have any effect on H. Why? Because L is separate entity as for INR. But if I am using INX at that time, it is 16-bit operation. Okay, so this instruction will have impact on all the like H as well as L, or B as well as C, and D as well as E. So instead of INR, see, instead of this LXI, if I write INR H, sorry, INX H, will it work? Will it work or not? What will happen here? D501 will automatically available. Same way, I can replace this and I can write INX H over here again. So see, now if you look at this program and this program and this program, it looks same. Okay, it looks same. Okay, the only difference is this first lines, and that first lines can be taken care by something. Okay, so what I want to do is, once I do this INX, then I am starting again with move. Okay, so what should I do? I should jump from here to here. Okay, so how to do that? I can do that by using this instruction, AMP jump to back. Where is back? Back is over here. Now see what happens. I have done something. I can remove this program now. Now let's understand what happens. Okay. Uh, just take it over here and then I should explain it. Okay, see what I'm going to do here is uh, let's take this to Excel. It would be best. I have taken this to Excel. Here I am going to write the content of register A, register let us say C, register H, and register L. After each instruction, what is the status of register A, C, H, and L? I am going to write that over here so you can understand what is happening. Okay. First instruction MVI A00H. What it will do? It will reset A to 00. Content of C I don't know, so it is XX, HH I don't know, L I don't know right now. Then A is still 00. Let me remove it as a text. Yeah. Okay. So now what is happening? I don't know the content of this registers. Okay. So this is my register A, C, H, and L. So now the content of A is still 00. Now I am moving 00 to C. So C will become 00. H and L is still not known. So I am just writing XX over there because it can be anything. Okay. Then what I am doing LXIH D500. Along with that I am moving one more register over here. Let me insert it. The register is B. Still XX XX. And along with that I need a data. Let me bring the data in. Okay, this is my data. I am going to use this data at some point of time. Okay, now what is the next step? Next step is I am moving D500 to HL pair. So this is 00, B is still XX. I should have it as a text. Text. C is still 00 and I am moving 00 and D5 in HL pair. So HL pair will become D5 and 00. Then I am writing move M to B. So M means HL pair. HL pair is D500. Whatever is the content on D500 will be coming in register B. Okay. So still accumulator is 00. Now something is moving inside B. So 99 is the number. C is still 00. HL pair is still D500. Now what is happening? Add A. So add A, what will it do? Sorry, add A. It should be add B. I have this, that's typo. Add B, it should be there. So add B, what will happen? A plus B. So A is 99, B is 00, 99 plus 00. It will become 99. Register B is there still 99. Okay, it is not going anywhere. C is still 00, D5 is still there, and 00 is still there. Then jump on no carry to forward. So during this arithmetic operation, as any carry generated, let's add a carry over here. Let's add a carry. I don't know the carry, but here carry is not generated, that I know. Here a carry is not generated, that I know. That's why I am writing carry as a 0. Okay. So carry is 0. So jump on no carry. There is no carry. See, is there any carry? No. 0 is no carry. So it will jump. So it will jump to this line. Okay. So when it jump to this line, what is the instruction? Instruction is INXH. INXH, what will it will do? It will just alter the content of H and L, and that content will modify to D501. Increment in this 16-bit data by 1. So it will become D501. Now again this program will repeat. Okay. Again this program will repeat. So why it will repeat? Because it is jumping back. So what it will get? it will get here back. So it will come back here. Now when it comes back here, what is the content of HL? It is D501. Okay. Just to explaining what is happening afterward, I am taking this block and I am pasting it over here. Okay. Once it jump back, this loop will start. Starting from move b comma m, it will start. Okay, and okay, now move m to b. What is the content of m? M is d501. So 85 is there. So 85 will come inside. Okay. B. Other than that, it would be 9900. No changes in other data. Only thing that I am changing is that line. Then a plus b. A plus b, but in programmer calculator. So it is a hexadecimal number. That's why I'm using this calculator. 99 plus 85. 1 E. So my answer is 1E, and right now my carry is 1. Okay. And 85 is still there, 00 is still there, D501 is still there. What will happen next? Jump on no carry to forward. But what is the status of carry? Carry is 1, so this jump will fail. And where it will go? It will go to next instruction. This is not a part of progress. It will come here. What will happen here? Here it will become 1E, 85. INRC is increment C by 1, then D5, and then 0, 1. Still carry is 1. Then what I am performing? I am performing INXH. So what it will do? It will only increment the content of HL pair by 1. So this will become D502. Again, which instruction is there? This instruction, jump back. Again, it will go here. Again, this cycle will start. This cycle will go on continuously until which point it will go on. That's the question. Until which point it's go on? It will go on forever. It will go on forever. Why it will go on forever? Because you do not have any instruction that can stop your loop. You have started loop, but this is unconditional jump. So unconditional jump can perform n number of times. So that should not be happening. So you should have a conditional jump over here. So how to form a loop using a conditional jump? It's very easy. Let's say I have a counter. Let us say I am moving a number in register D. The number is 05H. Okay, and then I am decrementing that D. What will happen when I use DCR at that time? It can impact zero flag, I know. Okay, so when I use DCR, D will become 05. Instead it will become 04, then 03, 02, and 01, and 00 sometime. When it becomes 00 at that time, your Z flag will set. So I can use jump on no zero instruction along with DCR to form controlled loop. Okay, so I'm going to do that. How I'm going to do that? So after DCRD, DCRD, after DCRD, I can use jump on no zero to back. And back should be at which position? At wherever you want to start again. Okay, so this is my starting point of jump. So now right now I am just for example I am giving this example. Okay, what is the content of D? D was 05 first. So it is first 05. DCRD, it will become 04. So Z flag will be 0. Jump on no 0 to back. If Z flag is 0, that means answer is not 0. Okay, or just do not see this 0 flag. Answer is 0. Jump on no 0 to back. Okay, jump on no 0 to back. So answer is 0. Okay, no, not 0. Is it true? Yes, it is true. Jump on no 0. This is non-zero, so it will jump back here. Again DCRD will become 03. Again jump on no 0 back. Again it will perform jump. Again 02, 01, and at some point of time it will become 00. When it becomes 00, jump on no 0. Is it 0? Yes, it is 0. So jump will fail and it will go to next line. This is how I'm going to form a loop. Okay. And now let us form that loop here itself. So what I'm going to do here is, instead of JNC, sorry, JMP, I'm going to use JNZ. Jump on no zero to back. Okay, but whenever I use this, I have to make sure that someone is becoming 0. So I am using resistor D as a counter. So DCRD as a counter, and as I am using DCRD as a counter, I need my counter to be created. So I am going to create my counter by writing MVID, comma 05H. Why I have written 05? Because there are 5 data bytes. I have to add 5 data bytes. So that's why I am using this thing. Okay, now let's again one more time check it back, whether it is performing correctly or not. Okay, I am only having the program that is important, and I am removing this part. Okay, so I need to add one more register now, and I need to add a zero flag. I don't need a zero flag. Let's have a zero flag. So earlier it is XX, till it is XX. I don't, whatever I don't know, I'll put X over there. Okay. Then once I know something, I'll start to fill in the data. So D is 05. So I know this is 05 right now. Then next step. Next step is HL pair is getting data. What is the data? It is D5 and 00. Then I am bringing some data inside register B. So I am going to bring some data inside register B. What would be the data? It is from memory pointer. Memory pointer is locating at D500 right now. So data is 99. So 99 is with that. Then addition between A and B. So it will only modify three things basically. It will modify the content, like it will modify this thing. Add B will modify first register A itself. Answer is stored inside that, and also it will modify carry flag and status of zero flag. Okay, zero flag will be still 0. Then jump on now carry to forward. Is there carry? No carry. So it will jump forward to this line. Okay, it will directly come to this line. Then once it comes to this line, what will happen? The content of INXH. So INXH will modify the content of HL pair. So this will become 0, 1. DCRD, what it will do? It will decrease the content of resistor D. Okay, so D will become 0, 4. Again, your carry fail and Z flag will modify, but it's still 0, 0. So again, jump on no 0 to back. Is answer 0? No, answer was not 0, or the 0 flag is not set. So it will go back here again. Okay, once it go back here, what is the current content? I am pasting current content first here. Right now your HL pair is D501, so it will bring number 85 inside. Once it bring 85 inside, your add B, sorry, your add B will add two numbers 85 and 99, and the answer is 1E, along with one carry, and zero flag is still 0. Once you have one carry, your jump will fail and you will come at this location. Once you come at this location, your INRC will increment the carry flag by 1. Okay. Then as soon as you increment by 1, your carry will reset. Why it will reset? Because INR can modify the content of carry flag as well as zero flag, but zero flag is still 0, 0. Then your INX will do the next task, and it will improve the content by 1, or increment the content by 1. Once it increment the content, you have next instruction, that is DCRD. What it will do? It will get this to 0, 3. Along with that, it will modify the content of your carry flag and zero flag. Okay, but as the two are 0, 0 right now, no effect on that. Again it will perform jump back. Okay, where it will go? It will go here on this line. Once it comes to this line, the line is M to B. M is D502, D502, A6 will coming in. So here this will become A6. Okay. As soon as it becomes A6, the next line will perform addition. So content of this three thing will change. Now let me perform the addition. A6 plus 1E. 1E plus A6. This C4. C4 is the answer. Okay. So C4 is the answer. Carry is still 0. Zero flag is still 0. Okay. No carry. So it will directly go to this line. See, it will directly come to this line. Okay. This line won't be executed. So I'm deleting this. And it will directly come to this line. Once it comes to this line, this will become 0, 3. Then it will go forward and DCRD it will become 0, 2. Again this 2 will modify, but right now it is correct. Again it will go back. Okay, so it will go back here. What is content of L? HL, it is D503. M to B will bring in 47. So 47 bit in register B. Once you do that, you are performing addition. So addition will modify this three things. 47 plus C4. So C4 plus 47. 10B. So my answer is 0B and 1 carry with 00 flag. That's the answer. Again, carry is generated. Okay, so it will come inside. Your jump will not perform. It will come to next instruction. So 0B 4701. So carry is generated. That's why NRC will be executed and your NRC will become 0, 2. Other than that, your carry flag will reset and 0 flag will reset. Again, your INXH will be performed. So your become D04. Once this become D04, and then you have control C, control V. Okay, here what will happen? Your D will decrement by 1, so it will become 01. As soon as it becomes 01, still your carry flag 0 flag is 00. Again jump on no 0, again go back. So it will go back here. Okay. Then your HL pin is D504. So content of B would updated by 52. This content. Once that is updated, it will perform the addition between 52 and B. So it will modify this and this and this. Okay, so let me perform that addition. 0B plus 52. It is 5D is the answer. So 5D is the answer. Other than that, 0 flag and carry flag will reset, so it won't come here and it will directly go to INXH line. What the INXH will do? INX will increment to D505. Again DCRD. What DCRD will do? DCRD will modify the content of D to 00. As soon as this becomes 00, your 0 flag will set. As soon as your 0 flag set, jump on no 0 back will not perform a back jump and it will go to next line. So now your 5 data byte operation is completed with and it has routed over 5 times, and now you are the program is waiting for the next line. So what is the next code? So next operation is to store the answer. Okay, so where I am going to store the answer on D505 and D506. Here I am going to store my answer and here I am going to store my carry. So right now, what is the content of HL pair? You can say D505. So I can directly move my answer to that location by writing move. Where is answer? Answer is inside register A. See, answer is register A. So 5D is my answer. Okay, along with the carry. So again, I have to increment by one location and then I can move my carry and then I can stop. Okay, so what this instruction will do? Let us check that one more time. Sorry. This will do nothing. Then this instruction will modify this to 06, and then when it is executed one more time, okay, sorry, what will happen actually during those two lines is this two content will be copied as 5D and 02. We have it as a text. Okay, so actually your answer should be this. Addition of this 5 data bytes to answer in 2 5D. Now let's check that. So I have my calculator. Okay, what I'm going to do, I'm going to add 99 plus 85 plus A6 plus 47 plus 52. It is 2 5D. Okay, that is 0 to 5D. So this is the correct way to do it with the less number of instruction. Okay, so this is actual program. We have started for this program 2 days back, and after so many instructions we finally reach at a word here, and I'll stop this programming here. So this is your correct answer. Okay, you can take a screenshot. You should have a question over here. A question, we have written the question 2 days back. Let me go to the question. Write a logical program to sound 5 data bytes stored in memory location D500 onwards and store answer in consecutive locations. So this is the correct program to that question. This is the exact program that you need. And I have shown you how it will execute inside your 8085. We'll see it in practical, like how it is exactly executed. Okay. But we'll stop here for today's lecture. If you have any query, you can ask. Any query is welcome.
No,
No,
sir.
sir.
You must be exhausted by now. Okay, we'll stop here.